Hello everyone, welcome to the NN Classroom. Today I'd like to share with you a past paper question from 2018 Time Zone 0 November, question number 8, a topic related to topic 13, the understanding or the concept behind the complex ion or complex formation. Let's see which is correct for the complex ion in this whole thing, right? So first of all, not a difficult one, a straightforward one, asking for the understanding of charge determination. So remember, first of all, students must be able to know that only within the square bracket, we'll be locating all our complex component. That means the complex ion can only be located within the square bracket. So that's why in this case, first of all, we can first remove the sulfate, right? So outside the square bracket are just the ions that form an ionic bond with our complex cation in this case. So you can see sulfate is of SO4 2-, right? So which means with a balanced situation, the whole thing has 1, sulfate also has 1, so 1-to-1 ratio. So sulfate has 2 negative charge, leading to the whole complex ion to be 2+, right? So that's why the charge state of the overall complex ion within the square bracket will be a 2+ situation. So now answer limited to only A and D. Make sense, right? So the first of all, and just remind you that the bonding outside the square bracket is going to be ionic. So which means the complex ion with the polyatomic ion of sulfate, which is always having a ionic interaction or ionic bond, right? But things within the square bracket are all about the dative covalent bond, or we simply known as the coordinate bond, right? Because this is a really famous feature relating to the transition metal ions in having the formation of this kind of dative covalent bond with all the what we call ligands, right? So the next step is within the complex ion, we look further. As we can see, iron, we are now looking for the iron oxidation state, or simply you can understand as the charge state, right? Yeah. For iron, how do we decide? Is that first of all, we decide the overall to be 2+, right? So that means the charge of iron plus the remaining charges, so the remaining oxidation states will be added up to be +2, right? We can imagine, right? So this is the deduction, right? And first of all, we see water. Water is also known as the aqua ligand, right? Water as a ligand has overall no net charge, right? So which simply means water only contribute to 0, no net charge, right? So times 5 of it, we have 5 of this water, right? And then finally plus chloride. So chloride is a halide ligand, right? So within this chloride, obviously we know chloride is of -1 charge, right? So that's why here we have -1. So finally, the math is like that, right? The oxidation state of iron plus 5 of the neutral, so which means actually it is neglected. And finally, -1 is going to be +2, sorry. So eventually, iron will gain a +3 oxidation state in order to be fulfilling this balance equation. So that's why we know that the iron is of +3 charge state. So that's why only the answer going to D.